So there is also a class example which I'll make available, which you can work through in your own time, which has a lot more clues towards the assignment. The past students have been told not to help with the calculations or the how to figure out how many bars there are, okay? Because it is an assignment and you're going to be getting 5 marks for presenting the reinforcing schedule correctly. And there's a bonus half mark in there somewhere, but I'm not telling you which bar it is. And that offers to everybody, obviously, and over above anything that gets answered in class. So reinforcing is something that I actually did as a job in England for a while, pretty much just a pencil, and I was checking reinforcing schedules for about a year and a half. It was quite well paid back in those days. I was working off plans, sketches similar to the one that you see there, where an engineer's sketched what they want, and you have to schedule that using your calculator and a pencil. And I'm going to take you through this little example here today. Hopefully you'll learn a little bit. What I can say is the bottom of this is a little bit like a concrete slab. It's a little bit like your assignment, especially the bars, how they bend up and down. So it would be very advisable to take note of some of the stuff that's going to happen on that board over there. So on that board over there, I'm pretty much going to fill that whole board up with calculation. I love this classroom. I get an English teacher or someone walks in here just after I've been teaching and sees all the board calculations, makes me feel good. So I'm also going to take you through an example AutoCAD drawing so you can have a little bit of a look at how you should be drawing up the bars. Once again, it's not exactly the same, but it gives you some clues towards it. Most things in engineering, as you go on to your second semester, your third semester, and your fourth semester here, and the past students will confirm this, some of them are on their last semester, you're given a problem and you've got to try and nut it out or figure it out. Very good ideas to get yourself into groups, make a booking in the library somewhere for a room quietly, or maybe just sit in the corner over there and try between you to try and nut out the problem. Because it doesn't get any better. You guys want to be engineers, you end up in offices, you've got the same thing. Here's a problem, you try and work it out. You'll have a few people in the offices you can help, they can help you, but they're not always available. So by the end of your training here, we expect you to be able to take a problem and work with it on your own. My job isn't to teach at the high level, my job is to show you and teach you calculations for stuff that goes on drawings. Some of it you may use in your working life, some of it you may not. And it's the same with every subject. So let's have a look at what this is and have a little bit of a think about what we're actually drawing. This is what we call a retaining wall, and it's anchored into the ground here. Sometimes they're anchored at the front and sometimes they're anchored at the back, depending on the design. Sometimes we put granular fill, and you should know from materials what that is, in your concrete and your aggregate labs. Sometimes we just put earthworks back behind. Normally, if there's a drain pipe to take the water away from behind the retaining wall, there will be some sort of fine filter material as well there as well. This one has got what we call blinding concrete, which is a strange name, but it's basically a weak mix that we put down before we make the structure. It kind of makes the ground a little harder, less boggy. This has got a construction joint in it, so it's a little bit like those slides I showed you in the lecture, where you have a starter bar coming up, and they lap onto that bar for the next bar going up. So that's something a little bit different. You don't have that on your calculations to do for your assignment, but I can tell you this much, you will have it when it comes to the test. So you're not totally wasting your time going through working out starter bars. We have a face, two faces of the retaining wall, which is this piece here and this piece here, referred to from the front face. The back face is where the dirt is that you're retaining. So that would be FF, front face. That would be, that would be NF, near face. That one there would be FF, far face. NF, FF, and if it's on both of them, we call it each face, EF. Okay. Anything on this part here would be kind of like the concrete slab. So you've got a concrete slab, so you probably should listen to this. Anything on there is classed as top or bottom. If it's on both, it's T and B. If it's on the top, it's T. If it's on the bottom, it's B. All right. Now, normally on a retaining wall, the same steel is on both faces. But if it's on an angle, which some retaining walls are, then that would mean the front bar would be slightly longer. So therefore, it would be a different bar mark. Bar marks are only exactly the same bar. So if it's that much difference, it's a different bar mark. Okay. Sometimes, if there's an overlap, they might use the same bar mark and just overlap it a little bit more. But most of the time we call up a different bar mark. Right, so that's what that is. And looking at that, we've got to do some calculations to work out the lengths. By the way, just to tell you how much the diploma has watered down a little bit over the years, this used to be an exam in this paper. This was an exam question. And to give you a bit of an idea, if you add that up, it's about 50 minutes. And that was how long we had to do it. I'll probably be taking about an hour to go over this today. Alright? In slow motion. So I'm just saying you guys have got 3 weeks to do your assignment, and you've got one more bar than we're doing today. So, yeah. Now we talked about bar marks in the lecture. This is on Moodle, by the way. If you're wondering, you can't see it very well, you can bring it up on your monitor. If you look at this first bar, number 01, 02, 03, and 04. Notice 03 is on the top and the bottom. 01 and 2. The 01 is all these dots everywhere, or donuts, and 02 is the bars that come down and touch on the construction joint. So we can write that down. First up, we can go 1201, 1602, 1603, and 1604. So the first one we're going to do is bar mark 1201. So it's basically all the donuts. So a bad student will count all the donuts that are drawn on my sketch and then put that onto the bar schedule. If you want to count them, the answer will be completely wrong. We have to work out exactly how many there are and put that on the bar schedule. So we are going to now start our calculations for that. In order to do this, we divide the retaining wall up into 3 sections. 1, 2, and a little bit at the bottom. Work out how many of the donuts are in each one. A little bit at the bottom. It's showing 2, but there may be 4. We're not quite sure. We can see a distance here of 300. What's the bar spaces? We roll up to the top and have a look. All bars are at 300 centres. We better write that down somewhere so we don't forget it. 300 centre to centre. Now that distance is basically a maximum. When we design in New Zealand, we design so that things don't fall down. So if you start going over that number, then you start getting a little bit of a problem. And what about the cover that we talked about? The cover is written there as well, 50 millimetres, just up the top there on the first page, 50 millimetres. So the cover, abbreviated to CDR, is 50. Let's go back to having a look at the sketch. So the bars must be at around the 300 centre mark. The sketch shows that it's 300 down from here to here. If we take away the cover, then we're easily going to be under 300 to the next bar. So the answer for that is actually exactly as it's done, 2 bars, as it's shown. Now I'm going to do the top one. The top one has a distance of 2,500 down to the construction joint. Construction joint is where they end the concrete pour before they pour the next piece of concrete. So we have 2,500 minus the cover up the top. So the cover up the top would be 50 mil, right? So minus 50. But we don't take the cover at the bottom. This is a little bit confusing, so I'll go over that again. We allow that bar that goes all the way up the top. Sorry, when we calculate, we do take, look, start again. We're doing the donuts, we're not doing bar number 1602. This is the 3rd time I've done this week, so I'm winging it a little bit. We take off the cover at the bottom as well. We can't have a bar resting on the construction joint because it'll be resting on the concrete you've just poured and you won't get any concrete underneath it. And that's the whole bar, and it's 5 metres long. You'll see that, that's too much. So when the bar's running that way, we have to lift it with the 50 mil cover. If the bar is like that, it can rest on the construction joint. There's only a little bit of the bar that's sitting there, okay? So 50 mil cover, so we take 50 off the top and 50 off the bottom. So we end up with 2,400. If we divide that by 300, which is the spaces, which I've written on the other board, we end up with 2,400 divided by 300. 8 bars. So we have 8 bars going down this way, and we have 8 bars going down that way. So we have to multiply that by 2, right? Which equals 16. 16. We all comfortable with that? Pretty easy calculation. What if I told you it was wrong? The 50's right, the 50's right, the 2,500's right. What if I told you that was wrong? We calculated 8 spaces, not 8 bars, 9 bars. I'll do it for you here. 1, 2, 3, 4, 5, 6, 7, 8, 9, which equals 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. 9 bars, 8 spaces. Right? Okay, well, it was a possibility of you getting half a mark there. No one last night, you'll be pleased, answered it, or today, which is good. So that makes 9 spaces 8 spaces equals 9 bars times 2 equals 18 bars. Right. Now we have to calculate them in the horizontal. The formula for the horizontal is slightly different. The formula for the horizontal, we have to work out the center line of that bar and the center line of that bar. So in horizontal we do it center to center. Any idea where that center would start coming in from here? Big chance for half a mark. Give us a number. 5 times the diameter. No, not too bad. That was an opportunity to yell out a number and get half a mark. Never mind. Okay, let's blow that up. Now I want you to all go to your technical literacy notes and work it out. That is exactly on the point at which the radius is tangential to the line going along there. You remembered the 2.5 from the lecture, that's very good, but you're wrong. It's 2.5 to the center line of the bar. You're getting close though. Do you want to have one more go? Give us a distance. I don't want to embarrass you, but if you want to have a crack, yell the number out, and then you can give me back the half a mark after that if you want. No? Okay. 50 cover, right? Like you said, bar diameter, which is 16. This distance here is equal to 2 times the diameter, which equals 32. Right? Now I'm going to tell you something that you can go and tell your maths teacher, and he'll tell you you've learned nothing here at Unitech. Tell your maths teacher that the internal radius of that bar is equal to 2 times the diameter. And he'll go, no, the radius doesn't equal 2 times the diameter, you really don't know what you're talking about. And tell him to come see me. Remember, I'll just take you back to the lecture. Strong man, bending the bar. Remember technical literacy. When Ingrid told you the 2.5 was what you had to do the P line at, but you gave it thickness, and the thickness was half a bar length either side, meaning the 2.5 became 2. Okay? So that internal diameter is 2. 50 plus 16 plus 32 equals 98. If we go to the other end, same thing, 98. What is that distance from there to there? $600 plus 400 plus 1,000. Now we're getting back to your maths level, guys. 2 meters, yeah. All right. So therefore, it is 2,000 minus 98 minus 98 equals. These guys didn't know is by pinching the front row seats, they become my little slaves. Calculator? What was that? 1804. 1804 divided by 300 equals 6.013. Gaps, right? Equals 7 bars times 2 equals 14 bars.
柱之间应该长。
Is that right?
But the 2000 millimeter, is that distance between two vertical columns or just one?
From there to there. We're calculating the bars, the donuts along there, right? 6.013, we've gone over 6 metres. Have we gone enough over to worry about it? Or do we just do what the guy in the CTT building did and just go, doesn't matter? It's only 0.013. Who's going to know?
美化竖着那个，就
If
是
there's
横
an
着这个，
earthquake,
你
I
这两
might
边
get
不
found out,
都
but
是
hey, we don't have them in Christchurch.
往回的这个圆弧吗？
Or is that acceptable in New Zealand standards?
就是他画的人就是这个，你不要想成这两边一边一个棍，就是中间这个。
0.2. Now I've done this in 3 lectures. In the test, you're going to completely forget that number. Just doing a bit of hypnosis here. You will forget it, okay? And it will be critical because nearly every calculation you're going to do in the test will go very close to 0.2. One of them comes out at 0.199 and the other one comes out at 0.21. If it's 0.2, if that was 6.2, you go up, right? So that would have been, instead of 6 gaps, it would have been 7 gaps in 8 bars. If that was if that was under 0.2, which it is, 6.013, you go down. So it is acceptable in New Zealand to go down when it's that close. So you've learnt something already. Guess what? The assignment's got one of those as well, okay? And I don't want you emailing, oh, it's 0.2, and I'll say, have a look at the whiteboard, you might see a number that might help, okay? Up, down. I can't do much more than that. If you want to ignore that, that's fine. Let's do, that ends up at 14 bars. So we've got 19 bars, 18 bars, 14 bars, and 2 bars equals 34 bars total. So we go all the way back over here, and we go 34. And we've only got to fill out all those other squares. We're only going to be here till 9 o'clock tonight. It's not going to take very long. The next one is the length. How long are those bars? The answer's there. It's at the top of the page. There are 10 5-metre sections. So this particular retaining wall is repeated 10 times, alright, but they're 5 metres long each time. So if the bar's 5 metres long, we've got to take the cover off each end. So that'll be 5 metres, 5 metres minus 50, which equals 4,900. Okay? 4,900. Does that make sense? Okay? So the difference between engineers and surveyors
这个东西，
is you guys do
这个是墙，
mechanics
往
and
里错一点，
structures,
你这个不能深。
and you know that you must use meters to get a calculation at the end in kilograms. You don't use millimeters, do you? Use meters for kilograms. Some of you guys are really smart at that subject, I know that. What the surveyors do is they put 4,900 down. At the end, when they multiply out, they get this massive number and they just give that to me. Okay? what the engineers do is they put a decimal point in here and they get it correct, don't they? All right? I only say that once. I'm looking at all the cameras. This here is in meters. What the surveyors do when they come to do that chart, this is last year when they were doing structures, is they did that chart in millimeters. Don't know why, and they got quite a few of their calculation questions wrong in my test. What the engineers did is they put the decimal point in and they got the calculations correct. You'll find that I'll be putting decimal points places in all of those. So that 5 meters, we really should remember that over here as well. So that's how long it is. Okay, the mass per meter. Now, most of the time you're given this in the assignment, you'll be given it in the test, and guess what? It's here as well. Can you see it? There it is on the table. 0.884. 0.884. Now, a surveyor would probably put 884 down there. Hold on a minute. Oh, that wasn't coughing. Now, can somebody do the mathematics to work out a total, please? Shouldn't take too long. Meanwhile,
所以那个 mass per meter 是给，
yeah.
我还没看明白他那两个拐弯这是怎么回事？为什么两个拐弯？
不就是这儿吗？这边一个拐弯，这边一个拐弯，这你就画一半儿，然后那个这直接在 offset 过来。这有一个拐弯，这有一个拐弯，看不这有啥看不出来的？
哦，那不是钢筋是吗？
他只不过没画这个而已，所以你看的不太形象。你以为是这边头和这边头，不是，就是这个小圆这个东西，不是。
Alright, so the answer to that is 147.27 kilograms. So this is in kilograms. 147.27. Okay, now the other two things we need to fill in is the location. Sorry, we've somehow lost the thing on the board there. I'll put it back again. The location is right, so the location of bar number 1201, it's on the near face and it's on the far face, so we call that each face, EF. It's also on the top and the bottom of the slab, so T and B. I think the model answer's just got EF, which is also acceptable because it's on every face of the object, but I would put, to be perfectly right, E, F, T and B. That's how I would have done it. And the sketch, it's just one big long bar. It's a straight bar, which is the sort I like to drink in. And also, we're going to put it over here, and we're going to put it down the word straight. No one picked that up. Okay? Straight. That's all we have to do. So there's no really hardcore sketch of that. The only two we're going to need to sketch up are the last two. So looking at the next bar, which is the one that goes from here straight up, 1602, there's two of them, but of course they go all the way along the wall. So that is also a straight bar. And that is each face. And we need to work out how many there are. So they go all the 5 meters. If you can imagine that this retaining wall goes all the way for 5 meters, we've got to work out how many bars there are. So that'll be 5 meters minus 50, which equals 4,900, divided by 300 equals, is that 18 or how much is that? 16 or 18? 16.333, is that right? Can someone do that calculation, please?
Yes.
Is that what it is? Yep. So do we go up or do we go down?
Up.
Up. So therefore that equals 17 gaps, which equals 18 bars, times 2 equals 36 bars. So this becomes 36. How long is the bar? By my calculation, it is 2,500 minus the cover at the top. So that'll be 2.450. And what is the mass per meter of a 16mm bar? Well, it says at the top of that diagram there, 1.578. In fact, they're all 1.578. And if we multiply that by, we multiply that by that, 139.18, close. Yeah, you're having a bad day. Maybe it'll improve now. Here we go. This one here, this one is a strange bar. Here it is here. And here's the other one. Now, my sketch shows this bar a little bit like this. So the sketch shows it coming along and going down, and that one comes up like that, right? Or something like that. Remember, it is only a sketch. I've done exactly the same thing in the assignment. With reinforcing, it's like when you're helping your grandmother do quilting, those things that fit on the bed. You always put the lines as far to the outside as possible. So the reality of that is this. The bar comes along and down, and another one in another colour, I've got another colour, goes along and up behind it or in front of it, so that we end up getting our 50 cover all the way around. Right? So now that we know that it's pushed right up against the edge like our grandmother's quilt, we can now do the calculation for that bar. So the bar goes from here to here. It looks like that. If we've got 50 there and 50 down the bottom, the bar is going to be 300, 300, and 1900. So let's go over here and do a sketch of that. And this is how we do it for the Steely. 0.3, 0.3, 1.900. So what the Steely does, the big guy I keep talking about, is you give him an overall length, and he marks out 300, and he bends it. And he marks out another 300, and he bends it. And then he puts it in a pile. There's quite a few of them, we'll work out how many in a minute. And when that pile's finished, he'll work on the next bars. And then from these numbers, he has to look at the plan and work out where they go on the drawing. Okay? So we're going to work out the overall length of that. So that'll be 300 plus 1900 plus 300, which equals 2500. Does everybody agree that's the right length? Okay. Don't say yes, you're having a bad day. What about the fact that when you bend it, you cut the corner? Like if I was racing you and you went all the way that way, then all the way that way, but I went just like an all black rugby player, straight for the point where I know where it's going to be. I'm going to beat you every time, right? That's why Richie McCaw, when he was so good at 30 something, he went straight to where the ball was going to be. Everybody else went that way, then they went that way, right? So, yeah. What I'm trying to tell you is you have to take something off that. And if you have a look at the chart at the top there, that is at the top of the page up there, it says 90-degree bend allowance. So for a 16mm bar, the bend allowance is 36. So we take off 36 and we take off 36, which means we go minus 36, which means that we end up with a new number at the bottom, which is 2.428. 2.428. 2.428. How many of them are there? Actually, it's exactly the same number as these ones, because that bar ties onto that, and that bar ties onto that, and they're all tied onto each other, and so they all step in 300 spaces all the way to the end. So there'll be 18 of those as per this. There'll be 18 of the ones on the bottom and 18 of the ones on the top. So that'll be 36. And top and bottom is what I would put there of the slab. So when we multiply that by that by that, we end up with 137.93. I'm going to tell you something right now, and you're going to forget about it, just like half the class forgot to put their design statement in the text box in Moodle. They also will, I'm going to tell you this, do not put that number there on your sketch. The black number there, do not put it on. Alright? Just the black. Do not put the black number on. You can put those two on. Yes? You put the black one on there and your steely's going to come. I worked on the Clyde Dam and the offices there were very, very shaky. They're on just prefabricated buildings. This guy would have been twice as wide as me and just about twice as high. And he was like Shrek coming down the corridor. You could hear him coming and you'd know someone's made a mistake, right? Okay, so as I said, 36, all right? Do not do that on your assignment. And you're not allowed to ask, do what? You're allowed to ask them. Yeah, so I just did that so you guys could understand what was going on. I know you understood what was going on because you were quite convinced it was 2.5, but we took a little bit off it, right? So the black is not to be repeated on the assignment. The bottom one is a bar that looks like this. And the way how I work this one out is we have the lap, and we go to the table up the top, and it says minimum lap for a 16mm bar is 520. So we put 520. Then it's 100. And then it's 400. And then it's 250, isn't it? Which is 250. Because it's 350 minus the cover. So 250. We add that all up, and then we take off 36 and 36. And we end up with a number down the bottom, which is 78.62. Wrong. 2.768. Yeah. That's the total. 2.768. 2.768, and the total number of bars is 18 this time because there's only one. Before we had 2, 2, 2. Now there's only just the one curved bar. So it's 18. And the total of that times that equals 78.62. And that would be each base, top and bottom. I haven't put the numbers here, so I need to put the two numbers here, which will be 1.270, 1.270, and at the bottom, 300, 0.3. But we're still not quite there. By the way, I said the lap was 520 because we had a 16mm bar and another 16mm bar. So the lap was, what would have happened if one bar was a 12mm bar and one was 16? Do you do the bigger one or the little one?
Bigger one.
Bigger one. Yeah, the bigger one. In New Zealand, you always go for the bigger overlap to make it stronger, okay? There's no two ways about that. You go for the bigger one. It's not, in this case, it's 2 16 bars, so don't worry about it. There's one thing missing from this chart that you're only going to find out from me right now that's really important in your assignment. Also, don't leave that out. Don't leave this out. What is it? Why have we done this? Because Roger said to.
Price.
Yep, we've done it for the price. So how do we work out the price? We need starts with T, ends in OTAL.
Total.
Very good.
Half mark.
You know, sometimes you just see that half mark sitting there and you go, it's like lotto, eh? You think you won it and then you look back, oh no, I got that number wrong. 300 and you're trying to hide behind your cell phone, I can see that. You're going exactly the same colour as the front of your cell phone. You're dead right though, well done. Total, 303, and you're not going to forget that, are you? You're going to be the first one to give me a total on the assignment. So the way how I do it is, I'm going to put my hand up now and I'm going to say no one's going to get this exactly right. How about that for being smarty pants on your assignment? But if you're really close, you might get your half mark for the total. Okay? Because when we cost, if it's fairly close, we've got a pretty good idea of what the costs are going to be. Okay? It depends who you're working for. I was working for an English company that were doing a job in Saudi Arabia, and they were getting paid 3 times more than they should have been. So they weren't too worried about whether they were close or not close with their costs, because it was a job where they were paying to do the job and getting paid for the steel, right? I then worked in New Zealand for a German company who were being paid by the New Zealand government, and the Germans were very precise. If you've never been to Germany, their trains arrive to the second and leave for the second. They wanted every cent from the job. So when I was doing my calculations, if I was out by 0.01, my boss would also come down the corridor. Unfortunately, he was a little man. He wasn't Hitler, but he sounded like it when he was walking in a bad mood, I can tell you that. And he would be straight into the office to find out why you did your calculation wrong. The other thing that I was under pressure for as well, and I was only 23 years of age, when the cages of reinforcing on the Clyde Dam, they were put onto a big lift that went right across the 500 metre dam, and then it went down into the dam, and it had to fit exactly. You couldn't be any more than 10 mils out when the cage came down with any of it, or it wouldn't fit. If it didn't fit, it got lifted back up again and taken back to where they were building it. And of course, with the Germans, that was, 5 minutes wasted, which would be 2 big concrete pours, which would be 2 concrete pours they never got paid for, plus 2 more concrete pours, bringing the cage back and putting it down, and also the wait time while the steely guy was chopping it to make it work, all because my calculations are wrong. All right. So the drawing office got the blame for time wasted on crane time. So yeah, that was pretty high pressure stuff. You had to check and recheck everything we did. So yeah, quite a big difference between working for a company that was working on a job in Saudi Arabia that was getting well paid and didn't care if they were a little bit out, and didn't care if they had to change things, for a company that was trying to get every cent out of the New Zealand government. So yeah, I want you guys to be as precise as you can. I'd like to see you do it, if you can, to the lengths to 3 decimal places, and the final total to 2 decimal places. I will give you this number in the assignment, and you'll have to work out the rest of it. So this is worth 5 marks in the assignment. There's 5 bars, okay? And it's got to be, you're going to have to work it out yourself. You have a question at all on that?
Yeah. Can you please explain the last one, 1604?
This one?
Yeah.
So that's the bar in the middle, this one here. Can you see my thing there? It's the bar that goes down, around and up, right? Can you see it there? Okay. So the lap, because it laps with the other one that goes up, the lap is on the table at the top up there is 520, plus the next dimension's 100, the next dimension's 400, but the last dimension's 300 minus the cover of 50, right? So that makes that one. It's repeated on the other side. The width of this is going to be equal to, if you have a look at the bottom, it says 400. So it'll be 400 minus the 250s either side is 300. You add all that up, then you take off your beam allowance of 36, and you end up with 2.768. Right? Now that was only half of what you're expected to do in 50 minutes in the exam. The other half was the quantities, which you have to do for me for the assignment. So to give you a little bit of a heads up and a hand, I've got a couple of model answers I'd like to show you. So take this away and we'll make it open. So the answer is there now, the model answers. There's two of them. One of them is what is behind me basically, but the other one is a bit of a sketch on how it's all done. So with quantities, you've got to work out the quantity of the concrete and also the fine gravel, sometimes the backfill and sometimes the excavation as well. And your one, you're going to have to work out the pipe, the drainage material, the excavation and the concrete. On this one, it's fairly similar in that respect. There's a thing called blinding concrete as well, which I talked about before. So here's my, this was my rough sketch of working through the quantities. And here's my rough sketch of how I work through exactly what I've got on the board behind me. Okay? Now I showed the other class this as well, but I didn't make it available for you guys before this class because I wanted to go through it step by step on the board so that you had a better idea of how it worked. And there we are, you can see there's the one you asked me just then, the bar mark 1604. Okay, and the other one is this one here, which is the schedule behind me. Okay. Now notice there's a difference in the schedule. Please just, I don't want emails on this. You notice the schedule says EF, EF, TNB and nothing. The nothing is actually wrong. It should actually say EF as well. But where I've put T and B, that is also considered a correct answer. I know it's a little bit confusing, but that's the way it is. When we label our bar marks, we start from the bottom of the structure normally. This one here is a bit different. We've gone from kind of the top to the bottom. It's only one structure and 4 bars. But if it's a multi-storey building, we tend to start with the lower numbers on the bottom floor and work our way up. So when they stack the bars, they can find them easily for each level. So if you really want to annoy the steely, you make the numbers all wrong on a building and you can't find them, and it really upsets his way of putting everything together. So when would you use this these days? Well, a lot of consultancies don't do this type of work because they just do the drawings and they hand it over to a subcontractor who will do the steel drawings with the schedule, but they're still responsible for making sure this is right. The engineer won't sign off until the reinforcing schedules are correct before they go into the ground. So even although you may not be the one that's doing it, you will definitely be the one somewhere along the line that's checking it. If you end up working for a contractor, a company like say Fletcher's or whatever, then you may be the one that's doing it, but you'll have a consultant checking it before you've done it. So I found in England that they were doing it as one big package, consultancies. So it depends where you actually end up working. Some reinforcing companies actually quote to do that as well as to put the reinforcing in place. It's all usually tied up within the contract anyway. So the other two things that I wanted to show you I'm going to make available on Moodle 2, and that'll be it. That'll be the end of me talking for the week. If you want to go, that's fine. If you want to make a start on the assignment, then you can start putting the title blocks in and that. and maybe thinking about what the plan view is going to look like. So let's have a look at the last two things I wanted to show. So I'd like to make available a example 2 with an answer, and I'm going to open that and show you. Okay, so this is a water race, and the good thing about this example is it brings into play all the different things you can think of for reinforcing, along with my example as well. So with this, I'll start by this bar here. This bar is a weird bar because it's floating in the middle of nowhere. Bars cannot float. It's at 600 centres, everything else is 200 and 250. The 200s run this way, so it doesn't matter. The ones running that way, namely this bar around here, is at 250. And we need to tie this bar onto this bar. We can't do that unless they're at the same spaces. So what are we going to go for, the 250 or the 300 centres? This time you're wrong. It's 250 because the 300's a bigger gap, so you're making the structure weaker. So you always go for the stronger gap, the shorter gap, to make the structure stronger. Luckily, you don't have that situation in your assignment. Okay? The other thing that you don't have in the assignment is, on this one they have a minimum length of 9 metres, but yet the length of the whole thing is actually longer than that. So you have to use 2 bars, so it's automatically telling you you've got a lap. Okay? And also, another interesting thing about this is they've got 50 cover at the bottom, but it says here all the other cover up the top here is 40. So that might seem unusual, but it's not. Often it's a different cover at the bottom when it's up against the ground. Okay? Apart from that, a lot of the calculations are very similar. You've got this curved bar here, which is a bit like our curved bar over there. Okay? And the good thing is that it takes you through it step by step. First of all, doing the quantities, so it's another quantities example. So it goes through doing the quantities, and it's a very neatly well set out one. I've always used this one in I got it handed down to me by my predecessor, and it's a very good way of explaining how you work out each bar. So if you have the time, if you go through this one, plus the one I did, you should have a very good chance of getting a good mark in the schedule side of it. So there it's showing you the distances. It even shows you how to work out the lap when you've got a lap, the distance when you've got a lap in the middle. You guys have got a lap in the middle. If you have a look at the assignment, your bar's lap in the middle. So that'll be a very good one to have a look at as well. There we are, here's the little sketch that I showed you. Notice it says the diameter and then it's got 2 times the radius. Hopefully that'll make a bit more sense now. And at the end of it, it's got a bar schedule, and you can use the abbreviation STR for straight, or you can write the number on top of it as well. But I'm perfectly happy with you doing that for the straight bars. Right. Now, if if you go back to have a look at this example at the top, I've drawn this up in AutoCAD. And you can have a look at that drawing. It's available on Moodle right now. And it'll give you a bit of an idea of how I draw it up in sideways view and how I've drawn it up in plan view. So I'm going to fire AutoCAD up, and as my very last thing to you guys, I'm going to show you the AutoCAD side of it. Okay, so the drawing is here. Saying do not use AutoCAD example. So this here is what we call a water race. In New Zealand, a lot of farmers use it to take, they'll do a water race structure like this to take water from a river across to somewhere on their farm, or from a pond on the farm to somewhere where they need the water for the animals or the crops or whatever. And there's a lot of talk of, on the news on the environmental side of the water and the runoff, and water races are used a lot to transfer the more pure water as well from point A to point B. So that's what it is, and this is what I've drawn. I've drawn that up, and I've drawn the answer up there for you to have a bit of a look at. Here it is here. So let's start with these bars here, the purple ones. Can you see them all right on if you open up the drawing yourself? The purple bars, oh, it's very hard to see. I'll make them white. All right, can you see that bar now? Yeah, the white bar, those wee white ones there, the donuts. Those bars in plan view, they go all the way, the whole length, but they have a lap on them like that. I would like you to show your lap hard up against the other one if possible, please. And that's how you show your lap. Now, I want you to note that on your schedule, it showed 20 of these bars, but on the drawing, we showed 5 there, 5 there, 5 there, and 5 there because they lap. Okay? Now I'm not going to say any more, but you're going to have to work out the differences between your bar schedule and the numbers and how you show them on your drawing and the numbers. And in some cases it's the same. In some cases you might have to split that into 2. And in other cases it's completely wrong. It's completely different. The next thing is I was talking about Tetris. See these numbers here? notice how my line comes down and it comes between the two letters where this is. That's perfectly acceptable where these are. It is not acceptable, I'm going to say this for the second time now, it is not acceptable to put lines through text. And that's what makes this drawing so damn hard to do, and it's what makes it really hard to do with an hour to go on Sunday. Okay? So don't put lines through text. This has been very cleverly thought out and put. I've got the other line up here. Notice it doesn't go through. That line misses the B. Oh, it doesn't. Let's move it along a little bit. Let's move that just a tiny little bit. There we are. So it doesn't hit the B or the 2. Okay? So that is critical when it comes to doing your assignment. Notice that these circles are about 2 times the diameter. I don't want emails saying, how big are the circles? 2 times the diameter. Right? And notice how I draw the delimiter bar. Now they're probably a little bit too big, but I would let you away with that leg, but no more. Probably about 3/4 of that size will be better. Delimiter bar represents the very end, the last bar, and it's only a very short little length. Perhaps maybe 3 times the length of the arrow, something like that. The width of that bar has got to be equal to the diameter of the bar itself. Now lastly, I'd like to introduce you to the yellow bar. Notice how the yellow bar curves and goes around here. Now I'm going to be a little bit mean here, and I'm going to tell you that when you draw this, you have to look back on your technical literacy notes, because we showed you how to do it in technical literacy with a P line, and I think you hit the right number before, exactly what that radius was, okay? And that's how you should be drawing it. You all did a little retaining wall, cycleway type thing. I can't remember exactly what it was in semester 1, but it had a curve on it, and we showed you how to do that. So you need to go back to that to draw the curve on your bar. If you don't know, you could actually list that and find out what that radius is anyway, and work out what the formula is for it. Now looking in plan view, you'll see something that you haven't done before. Here's what the yellow bar looks like in plan view. Let's go to the end of it, and guess what? It's got a donut on the end of it, because it goes down or up. And the only way we know it's going down or up, yep, so looking at that, here's the sideways view, and looking in plan view, all you can see is the donut on the end, right? I need one more pen to demonstrate this. Maybe I can. So yeah, you won't bite me. Get back to there. Just a student of keeping. Okay. So that's, yeah, let's do that. So that's your U-bar, right? But when you look down on it, that, you just see a donut on each end, don't you? So that's how we show that the bar, but we can't tell whether it's coming up to us or whether it's going down that way. So that's why we should always show 2 views of reinforcing. Now I'm not making you do it for assignment 1, but on assignment 2, I expect that you'll show the elevational view, okay, of the, yeah. So on assignment 2, I would expect that you'll show the bit at the bottom with the reinforcing, because it's not a proper set of structural reinforcing concrete if you don't show 2 views, because you can't work out what those donuts are all about. Any questions apart from stud mullet ones? so you just in summary. Just in summary, we've got an example we went over today in class, right? There's also some quantities there if you want to see how the concrete's been worked out. We've also got another example which I just showed you with the water race, and the answers to that are also there if you keep rolling down. And you've got I've also given you a CAD drawing where you can have a look at that, and you can start drawing your own drawing of the foundation slab. Next week we move on, we do steel, and we do steel schedules. So you can, between now and then, you can start drawing your plan view, and you can start doing the reinforcing schedule. I would suggest you should do this first, because then if you get this right, or most of it right, it'll make it easier to do the plan view, because you'll be able to work out how many bars there are, etc., etc. Okay. Now we stop talking.
Is there a cross section here for that layout one?
顺便咱们画不在位，我这作业
No, we don't. And assignment for you, we do that. But I did suggest that it's a good idea to do the cross-section view at the bottom, out of the viewport. I want to see it in the viewport, so you can project your line down and work out where it will go. And then that won't go to waste, because that can be part of the assignment for you. Work it over. As long as you don't put it in the
Okay, sounds good.
yeah. Just like I've done here with this one here, as you can see, I've got the sideways view, and then above it, I've drawn my view that way.
Oh, cool.
See? But if that was the assignment, I would have the viewport looking at the top bit. Because it is worth, the reinforcing's worth about somewhere between 1 and 2 marks in the second assignment. About 1, I think. So you haven't wasted your time in terms of that. So just to recap, remember guys, the title block that's in there, you may have to scale that by 2 if you want to use that one. You can use your title block from assignment 1. You're not allowed to go save as of your assignment 1 and 2 to start your new drawing. I don't want you doing that. When you're starting a brand new drawing on AutoCAD, File, New, ACAD. Okay? Very good reason for that. I'm finished talking now. Roger and out.